Welcome to Chapter 2. Here we're going to look into the topic of logic. And what you'll notice in this chapter is we'll never do any calculations where it's all about logical statements and whether they're valid or not. And so that's what we're going to be looking at is logical arguments and trying to determine their validity. But in order to do that, we need to lay a foundation. What's good about this chapter is that logic is not something that we see that's been students are exposed to. In fact, most of the students I have in a class will not have seen the concept of logic before. It's possible though, and sometimes not even in a math class, in a philosophy class, they'll talk about logic and logical statements. And again, the whole goal is to determine the truthfulness, the validity of an argument. And so we do that through what's called symbolic logic. And we start here with the foundation of everything that we're going to do. And the foundation is in these statements and qualifiers. So a statement has a very specific definition, is a sentence that is either true or false. Now, you may not know whether the statement's true or false, and that's okay. The question really is, does it have to be either true or false? And we'll give you some examples. Write true a little bit better there. So that's it. It's it. A statement is a sentence that is either true or false. So when you get into the homework, one of the very first questions they're going to say is, hey, is what I'm giving you a statement? And so it could be something like this. It could be the sky is blue. So that statement is either true or false, right? And so therefore this is a statement. So that sentence is either true or false. So it's a statement. They could have something like this. 6 is a multiple of 3. And that statement, well, that phrase is a statement because it is 100% true. But even if it was false, it would be a statement. So we're not determining whether something's a statement, and maybe that was a bad thing for me to write. We're not determining whether something's a statement based on it being true. We have to know whether it's true or false. So here's number 2 in the homework. All odd numbers are divisible by 2. Now, you may not know the answer to that. Hopefully you do, but if you didn't, that would either be true or false. We'd have to look at every odd number out there and see if 2 will go into it. And if it does, then the statement is true. If it goes into every single one, the statement's true. If there's one odd number that does not work for, then it's false. But still, in both cases, this is a statement. You are not being asked, you are being asked to determine whether they are true or false. So this is a statement. All odd numbers are divisible by 2. Is that true or false? That's false. Numbers like 3, 5, and 7 are not divisible by 2. All even numbers are divisible by 2, but all odd numbers are not divisible by 2. So that statement is false. But in particular, it's a statement and it's false. The one above that I did is a statement and it's true. And the sky is blue, that's a statement, and that is commonly believed to be true. Okay. Then we have something like number 4. Number 4 says, robot, what is your function? And this right here, we would look at that and what is it, a statement? No, it's not even a sentence. It's a question. So this is not a statement. Okay. So it can't be a matter of opinion. It can't be a question. It's got to be something we either know is true or false, right? Or something that can be true or false. Again, you may not know until you look it up. So here's number 6. 8 minus 3 is equal to 5. Sometimes they use mathematical phrases. This one is a statement because it's either true or false. Is 8 minus 3 5? Yes, so it's true. Okay, and so that would be our answer for that one and not a statement for this. And so the first few questions, you're just going through and determining, is that a statement or not? The next ones that you're going to see are a little bit strange. We want to start getting into symbols. And so there's two symbols. If statements are represented by symbols, and it's usually a letter, in fact, always a letter. The most common ones are P, Q, R, W, putting them in order of how we see them. S is commonly used, T is commonly used. All of these will be used to replace a statement. That way we can work with them later on and determine the validity of the statement that's being made without having to rewrite everything. Once, a lot of times with language, and you've seen this with politicians, they can be very clever. If we put things in symbolic form, it allows us to analyze the argument without any bias, which is always awesome. And so you have these directions here for the next group of problems. It says, for the following statements, write each in symbolic form. Now, later on in other sections, this will be more of an ask. It's a little bit strange to write it here, but they want to emphasize that statements have letter representation. So number 10 says this: Bruno Mars performed during the Super Bowl get that W looking better. Super Bowl twice. Okay, I believe that's true. But you're like, well, what do I do with this? They're not asking if it's a statement. In fact, they're telling us it's a statement. They're not asking us whether it's true or false. They're asking us to put it in symbolic form, and this is all they do. Hey, P represents Bruno Mars performed during the Super Bowl twice. Right? So now P represents this statement right here. I could use it anywhere else, but you define it in that guy. Okay. So this takes place through about a little bit less than half the homework. And then the rest of the homework focuses on a concept of a negation. There's where the qualifier comes in. The negation, I'll write that, the negation of a statement. So the negation of a statement actually has a symbol. The symbol for the negation is this wavy line, sometimes called tilde. If you were to find it on your computer, it would be right next to the number 1 on that top row of numbers. There's a little tilde sign there. But it's this single wave of a line. And what that means, then that means to negate the statement. So that's the symbol for the negation. So let me put that in parentheses. That's its symbol. And what this negation means is the negation of a statement is its opposite. Okay. The negation of a statement is its opposite. So if P, the statement P is true, then the negation of P would be its opposite, would be false. Similarly, if P is false, then the negation of P would be true. Okay, so the negation is the complete opposite of it, and we need to be careful. So most of the time, it's pretty easy, but if they ever used an absolute, we got to be very, very careful there. So let's take a look at some statements. Elephants have big ears. So they would like us to write the negation. So here's the statement, elephants have big ears. Its negation is simply what? Well, if that's not true, what's the opposite of elephants having big ears? Elephants do not. In fact, let me back that up a little bit and put elephants and then switch to red. Do not have big ears. Just to emphasize what's being added. So it can be very simple in what you have. Your original statement could be something like this. Nature's first green is gold. Sorry, let me spell that right. Is gold. That's a statement that they have. Oh, actually, they have it like this. Apologize. That's why I picked it. Nature's first green is not gold, is what they have as their original statement. So the negation of that statement, which they want us to write, is nature's first green. And so what's the opposite of nature's first green is not gold? Well, if that's not true, then nature's first green is gold, right? So we just remove that not in there. So where does it get a little bit tricky? It gets tricky when we say something like this. All students passed. Now, let me highlight something. This is the reason why it's tricky. For all students, what's the opposite of all students passing the class? Well, it's not all students failing the class. In order for all students to have passed the class, what has to happen? Every single student has to pass. So if that doesn't happen, then the negation is some students did not pass the class. The opposite of an all, a universal qualifier, is to have some. So in order for all students to pass the class, every single student has to pass. So for that not to happen, at least one person or some students did not pass the class. So they have that in here, right? Number 20 says, here's number 20, all cars have wheels. If that's not true, then what we will see are, and let me be careful here, the negation is some students did not pass the class. And the negation is, well, if I'm looking out and I don't see all cars having wheels, then I see some cars do not or don't have wheels. That's the only way that that's going to be false, is if I look out there and see some cars that don't. If I see a car with wheels, that's not a problem. That means, everything I've seen so far has wheels. But the moment I come across 1, 2, or 3 that don't have wheels, then all cars having wheels is false. So the negation is some. And they work it the other way as well. At least I thought I saw that. Oh, yeah. Number 18. The original statement is some dogs like cats. So let me do the whole negation in red this time. The negation would be, well, what's the opposite of some dogs liking cats? If you don't see some dogs liking cats, then what are you seeing? You're seeing all dogs do not like cats. You're seeing every single dog not liking cats. Otherwise, you'd see some dogs liking cats. So the negation of an all is some. The negation of some is all. Okay. So we have some flexibility in the wording. It doesn't have to be exactly the same, but we have to communicate the same thing. And so you'll get an opportunity to practice as you go through the homework. And so what you want to do is come up with your best answer, flip to the back of the book, and hopefully it matches. If it doesn't, see if it's maybe the same, or see if you need to adjust. And if you don't know how to adjust, that's when you reach out to me and say, hey, I don't get this one, Jensen. So then they go for the last little bit. They go into writing the negation of each statement symbolically and in words. So this is number 28. And let me go back to black. So number 28, towards the middle of that section, says T. Nobody messes with Texas. Okay, the statement. So what they would like us to do is write the negation. The directions are to write the negation in symbols and in words. Okay, so as I go to do the negation, I'll do it in a different color. So that if T is the original statement, then the negation of T is it symbolically. And what's the opposite of nobody messing with Texas? Now, nobody is nobody. It's all, right? No person messes with Texas. So you don't need everybody to mess with Texas for that to be false. You need somebody messes with Texas. That would be the opposite statement, is to have somebody mess with Texas. It could be something like, I'm going to go before that because there was a reason I skipped 26. Let me show you what 26 says. 26 says the negation of Q is my favorite superhero does not wear a cape. Okay, so when we go to do the negation, got to be really careful here. Well, what are we negating? We're negating the negation of Q. But the negation of the negation of Q is simply Q, right? The opposite of Q is Q, much like two negatives make a positive, right? Negative of -1 is just 1. So you don't actually have to write the double negation if you don't want. You could just go straight to Q, but I wanted to stress that. So it's probably best for us to just say, oh, the symbolically the negation of Q is just Q. And the opposite of my favorite superhero does not wear a cape is my favorite superhero does wear a cape. Right? So if somebody said, well, Jensen, can I just say my favorite superhero wears a cape? Absolutely. There's always more than one way to write it. I just happened to choose this first. And so as long as we're communicating the same thing, we should be really, really good. So that continues for a while, right? They're having us translate statements into symbols and from symbols to words. And that continues up through problem number 39. And then from 41 to 45, actually 41 to 47, they are asking for you to just think about a logical conclusion. So let me show you what 46 is like. So they want you to use your intuition here. They want everybody has a logical part of them that just sees the way things should work out based upon what's said, and they just want to make sure that we don't lose sight of our intuition as we move forward. So 46 says penguins are flightless birds. Then it says emus are flightless birds. Then it says ostriches are flightless birds. Oh, sorry, I'm spelling that wrong. That did not feel right. Ostriches are flightless birds. And then they ask a very funny question. Or you could look at that and be like, I don't know what you want me to say. But they say, what conclusion can you draw from these premises? Now, as we move on in the book towards the end of this chapter, we're going to be evaluating logical arguments. And premises are all the things that we know. Conclusion is what we believe happens because of those premises. And so they're going to come up with some premises and a conclusion, and we're going to test the validity. Right now, they want to say, well, what if we told you penguins are flightless birds, emus are flightless birds, ostriches are flightless birds too? What conclusion can you draw from these premises is the question. And so you think about it, you're like, well, I don't know what you want me to say. Well, try not to overthink it. From this, we would be absolutely able to say some birds are flightless. They didn't list out all birds, so I can't say all birds are flightless, but I definitely can say some birds are flightless, right? And we absolutely know that all birds are not flightless. So, right, there's some birds that fly, right? Probably most. But we can say because we know penguins are flightless, emus are flightless, and ostriches are flightless, some birds are flightless. You could be thinking to yourself, well, all you needed to tell me was penguins are flightless birds, and then I'd be able to write that. Absolutely. I'm not sure why they did 3, but just to get you to think. And so they'll have others in and around this area where you're just looking at the premise and saying, well, what could I potentially conclude there? And so as we do a small recap, the first thing is that we have statements. Statements are either true or false. We represent them symbolically as we move on in the chapter. We have this idea of a negation, which is its opposite. Opposite meaning it has the opposite truth value. So, and we can quickly take the negation of each statement, which is a majority of the homework. And then in the end, we're given some premises and asked to come up with some conclusion that we feel makes sense based upon the information that's given to us in the premises. So I think you'll have a good experience with this section, but as you have troubles or difficulty, reach out to me. Thanks for watching.